This is an AS statistics question on probability. A factory buys 10% of its components from supplier A, 30% from supplier B, and the rest from supplier C. It is known that 6% of the components it buys are faulty. Of the components bought from supplier A, 9% are faulty, and of the components bought from supplier B, 3% are faulty. Part A, find the percentage of components bought from supplier C that are faulty. Now, to help me do this question, I'm going to draw a tree diagram. So I'm going to use 3 branches here to represent the 3 suppliers A, B, and C, and the percentage that come from each of those suppliers. Supplier A is 10%, supplier B is 30%, and the rest from supplier C, so that's got to be 60%. And I'm going to use F and not F to represent the component being faulty or not faulty, like this. And then I'll put those probabilities on as well, or as much as I know. So starting with supplier A, I've been told that 9% are faulty. Okay, so let's put 9% being faulty here, which means that 91% are not faulty. At supplier B, I'm told that 3% are faulty. So that means that 97% are not faulty. And I need to find the percentage of components bought from supplier C that are faulty. I'm going to call that X. Now, what I know that in total, the percentage of faulty components from all of the suppliers is 6%, and I can use that to work out what X is. So the probability that it's from supplier A and faulty, plus the probability that it's from supplier B and it's faulty, and the probability that it's from supplier C and it's faulty, is equal to this 6%, 0.06. So let's work out what these probabilities are. So the probability of A is 0.1 times the probability that is faulty is going to be 0.09, plus probability that it's from B is 0.3 and it's faulty is going to be 0.03. And for C, it's going to be 0.6 times by X, the probability that it's faulty from factory C, and that total probability is equal to 0.06. So that gives us 0.018 plus 0.6x is equal to 0.06. And so from here, we can say that 0.6x is going to equal this 0.06 minus 0.018, and that gives us 0.042. So from here we can work out X. So that'd be 0.042 divided by 0.6, and that gives us 0.07. So the percentage of components from supplier C that are faulty, from supplier C that are faulty, that's 7%, is 7%. Moving on, it says a component is selected at random. Part B, explain why the event the component was bought from supplier B is not statistically independent from the event the component is faulty. So what we need to show is if the probability of B and faulty, not F, is equal to the probability of B times the probability of not F, faulty. So we did work this bit out before. It's just here. So the probability that it's from B and it's faulty is equal to that 0.3 times by 0.03, and that's 0.009. And now we're going to do the probability of B times the probability that it's faulty. So the probability that it's from B is 0.3. Now the probability that a component is faulty is this 6% here. That's the probability it's faulty. So not B and faulty, but just faulty. So 0.3 times by 0.06. That gives us a value of 0.018. And then we can say that since, let's just give our values, 0.009 is not equal to 0.018, the events B and F, not F, are not independent. Let's just highlight that.